Hi everyone. We are going to solve all unique permutations of an array. In this question, we are given an array of length n and we have to return all unique permutations of this array. So you can see in example 1, the input array is 1, 2, 1. Okay. And the permutations will be 1 to 1 itself. Okay. Then 1, 1, then 1, 1, 2 and 2, 1, 1. Okay. So, and again, for example, 2, array of length 2, 4 and 5, it will be 4 and 5 itself and then 5 and 4 which is given in the output you can see. So I will solve this question. You can solve this question in Python using inbuilt dictionary, but that will not help us in learning the problem solving approach. I will solve this question using backtracking. Okay, so first I will create a result variable and a dictionary, empty dictionary, so that this dictionary will keep the track of all the combinations which have been seen, which have been already visited, already calculated. Okay, so in order to avoid any repetitive calculations. Okay, now we'll create a backtracking function, backtrack, and I will pass two values, I and ls. Here I is the current index and ls is the current state of the array or list. Okay, and in the beginning when I will be just calling this function in our main function, the input parameters will be 0. 0 will be the current index to begin with, and array itself will be the current state of the list to begin with. Okay, and at the end I will return this array. Okay, so again I will reiterate that I will pass I and current state of list or array. Initially the current index will be 0 to begin with, and current state will be the array itself. Now to populate our backtracking function, so there will be obviously two conditions. One is the base and another will be calculations. So get the base condition if I equals to n. Okay, so in the base case when I is equals to n, this will indicate that all the elements in the list have been considered already. And in this case the function will check the permutation which is represented by the current list. We check the permutation which is represented by current list is already present in the dictionary or not. Yes, if not, d dot, and it will be in format of tuple. Okay, if it's okay, if it is not present, the permutation will be added to the result list. Okay, which is the res in our case. Okay, this okay. If not in the ls, then in this case I will just append this in the result list. Okay, I just appended it, and apart from that, so what I have done over here is I have I have just copied its representation as a tuple in the dictionary, and at the end I will make it true. Okay, now it's time to return out of the function. This was the base case, and if we are not in the base condition, okay, if the base condition is not met, then in this case the function will enter a loop where it will swap the starting element from the current index I with all the elements that comes after it. I will reiterate. Now here it will enter into a loop, and it will swap the current index with all the elements which are coming afterwards. Okay, for j in range I to n, because it will start from the current index and go till very end of the array, and here I will swap, and ls is, as we already know, it is the current state of the array or list. Okay, now, and then it will recursively call itself with the updated index and the list after swapping the current element with the afterward element. It will recursively call it the updated list. Updated list is what? I plus 1. Since I we were already in the I, and the updated current index will be I plus 1, and array will be the array itself will be the what? Updated list. Okay. Okay. Now, as we know that in backtracking, once we have been we have called ourselves with the updated values, we again change the we again backtrack to the values if that was not the case. Okay, and we'll again call. So as I already mentioned, this swap is reversed here in order to restore the original state of the list. Okay, and since we all know that backtracking, this is the most crucial step in order to backtrack. This is the real backtrack. I will mention it in using comments. Okay, so this step is what backtracking is. Okay, here we are doing the backtrack. Okay, so this does our job, and since we have already passed the initial parameters and returned, let me compile it first of all. Hmm. Okay, I have to return this sorted one, not the. Yeah, yeah, I have to return the sorted one. Let me submit it this time. It should do a job since it was already giving the correct result and were just not in the order. It is doing the job. It is doing the job. Okay, so as you can see, it took some time since we are using backtrack and which in turn uses recursion. But using the dictionary, we have avoided repetitive calculations, so it saved our much important time. So I hope you enjoyed it. Thank you. Have a nice day.